Welcome to our talk. This is about memory and database object persistence, as you can see. This is about like an experience report, if you want, and about some ideas that we have at Mercap about how we face the problem of having these situations with having to persist objects in a relational database, but wanting to keep things simple also in memory for test-driven development and simpler developments. Just to give you an idea of how we work, if we have a functional requirement, we will sit and with the group think about the problem. We want to apply test-driven development to all our tasks. So we will decide how to approach the problem and then model the domain objects using test-driven development. And also we will have what we call user story test. The test-driven development will give us the unit test for the domain object, but also what we call the user story test for the systems, because our application works with a layer of systems. That's something that's been talked about here at Smalltalks. We have different systems that manage different parts of the application, and always a user request will always impact the application through one of the systems. User will never touch directly the domain objects. So we have unit tests for the domain objects and user story tests that will check how the systems work and interact between them. So something more about our development context. Our customers are mainly banks. We work in the financial industry. So banks have this requirement mostly that you have to use relational databases because they have their administrators and that's what they work with. And we have been using for years VA Smalltalk. So we say, okay, we have to do this new application mainly for banks. Let's use Glorp that will manage our relational database requirements. And since we decided to use the Glorp version for VA Smalltalk, which we learned yesterday that is going to be improved, and we are very happy with that, and we have this system architecture for the application. Say, okay, if we have a system for every part of the application and we need persistence, we will surely have a persistent system somewhere in our development. So how do we go about doing testing? We love doing test-driven development, but there's this problem when you have a relational database that could block a little bit the design decisions. We do not want to decide how to reify and model our domain objects because of the way we have to persist them. So, but we have to have some tests on the relational database. So you could either go and test everything on the database, which is something that our previous products used to do. You could say, no, I don't care about the database, my main focus will be the model, so you'll be using test-driven development and ignore everything about the database, and then we'll see in production how that goes. You can see, okay, let's do the test-driven development, let's get all the objects, the domain object and the systems, and then let's do some additional duplicated tests to check database performance and check that everything's going fine. But this talk is about a fourth way that we are going to tell you about, which is about abstracting the persistence layer with something that we've called the managed objects. These managed objects are abstractions for the collections, the stuff that every system will handle. If we have a customer system, it will have customers, and so instead of, I don't know, a collection, if we were doing something in memory, or maybe a table for the customers or currencies that our financial system uses, we will have managed objects. This layer of abstraction will in memory work with a collection. If you have to filter them, you will use something like select something. And if you are using the relational database, we will persist them in tables and filter with where, select, and the usual stuff. So if we have everything with systems, we will obviously have the persistent system, as I told you before. This is an interface in this case because we can have two different implementations, the in-memory persistent system and the relational database persistent system. And now we can do the test-driven development as usual, and the setup of the test will decide when creating the composite system if we want to apply one of the implementations or the other. The tests are exactly the same, and now we can do fast testing if we want, do the test-driven development, no problem, and then when we're finished with the unit of work, we say, okay, let's integrate this into the base product, and we can switch and check and test everything again, but this time on a database using glorp, and well, Julian now will enter into the details of how we do that.
Okay, I'm Julian. As Tavi said recently, we work with managed objects. Managed objects are managed by are the abstraction for the collection of objects that the system can use. When a system wants to register or to obtain a managed object, it talks with the persistent system and registers a managed object with a key. Then the system can access the managed objects with that key. It's basically a symbol that you use to recognize them. As said before, we have two different implementations of the persistent systems, which lead to two different implementations for the persistent for the managed objects. In memory, it's just a wrapper for a collection. It delegates most of the messages to the collection, and when using a database, the managed objects interacts with the persistent system, which has the necessary objects, the glorp session, and which was previously configured with all the descriptors needed, which I will talk soon. These descriptors, these things you need to, are objects you need to define when trying to map an object to a database. You need to define a class model, meaning the shape of the object you are going to define, the things that you want to persist. Table, meaning you describe the table you are going to persist the object, or tables. You define the columns and the types. And the most important part, class descriptor, which connects the class model with the table. The class descriptor says, okay, this attribute goes into this table, this one goes into the other, I want to define a custom mapping for this one. It's the most complex part. Those are glorp concepts, intrudes are object relational persistence concepts, and we define over those persistent concept definitions. We define an abstraction that explains how to create them. It's a description of code to create those things. Why we did that? Because we work on a system implementation, and we try to make things modular, and we did not want to we did not want the persistence layer tied to the definitions, and we want to swap in memory and database without having the requirement for the glorp objects. How does this work? In the center of all this is the glorp descriptor systems when working with database. These descriptor systems needs to be configured before anything with all the previous descriptions, the class models, the descriptor, the table mappings. But this needs to be configured all at once. Due to our modular implementation, we needed to split that. So we implemented a configurable descriptor system that basically you tell them you can add things in runtime, saying, okay, I will use this class, I will have this table. It's basically configurable. Both things are embedded in the persistent system, and it's managed by the persistent system. Nothing outside the persistent system knows about the configurable descriptor. What you have outside are the definitions, not the real objects, the real glorp objects, just the definitions. The definitions explain to the persistent system what do they need, and the persistence implementation decides that in memory it just doesn't do anything. In relational database, they defines how to create those glorp objects. Okay, up to here we have a persistent system. You tell him to add something, and it stores the object. You have all the objects in the database. Most important, you need to retrieve those objects. To retrieve those objects, you need to perform a query. In Smalltalk, you apply a select. In database, you apply a SQL query containing a where select select clause. To represent that, we implemented query filters. Query filters technically represent a where clause in a SQL select. It contains requirements. It's meaning the Boolean operations of the things you need, the object that the restrictions represent the things you need the object to conform to be in the response of the query. Those requirements then are mapped to glorp expressions, then glorp maps to query field to the final SQL query string. And in memory, it just translates again to a select. It's an object that returns true or false in the select clause, and it applies. Here is a little example. You have a user system. You want to query the users with a given role. You say, okay, user system, give me the user filter by query filter. That query filter expects that all the users with a given role, the user's roles is equal to a role. That in memory it maps to user role equal to role, and in glorp maps that to the select string, that select asterisk from user where blah 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 blah. We implemented a variety of query filters. Here are some examples. Comparison query filters. It's the one we saw before. It's sending of a message and then that result compared to a Boolean operation. Composite query filter for composing if you need both either and or operations. Delegating query filters that it's in memory it would translate to sending a sequence of messages. In SQL it will translate to a subselect. Membership and inclusion, that is an object is in a collection or a collection includes an object. And the null query filter, if you need to have a query filter and you don't really want to filter anything, it's just return the whole collection. About what we have, what we think in this moment, it's as we presented at the beginning, gives us easier testing. We test initially with the in-memory system. We write tests as you usually do in any Smalltalk environment without worrying about the persistent layer. Once you finish with the test, you have a model that you like, that you change many times as you want. You can change the persistent implementation, that is abstract, and then the test will obviously fail because you didn't define all the required mappings and objects necessary. But it helps you to define a model that you like without having to worry about that. You just change the way you run the test, and it's a whole new set of tests with the database below. Limitations. When you are debugging, we added another layer between the database, then glorp, and then our descriptor system and their own model that leads to complex debugging. Just when using the relational database. When in memory, it's simple. It's as it's just a wrapper file collection, it doesn't bring much more complexity.
So that's what we've been doing, and the benefits that we found. About what we want to do in the future, there's still a need to improve the mapping of complex relationships, because this has allowed even people who are new to the application to develop very quickly, to use Testdriven development to map everything to the database easily. But once more complex relationship appears, when we want to do some better performance development, and if you require some changes to the model in order to have better performance in the relational database, you are leaving something behind, because we don't want to conform our domain objects to the database requirements, to the table structure of the relational database. So we still want to do some improvements and maybe some better builders and assistants to help us get the mapping we need in the database without giving way and losing the domain object that we wanted to define. Also, now that we are working in the database, there are instances where we might want to do some massive update. If the user chooses, hundreds of objects and wants to do some confirmation of transactions, for instance, we might get better performance if we did just one update with the right filters. But in the current implementation, we still don't get that possibility. So we intend to work on that. And also, once we have the database, means we have everything access to the system. Sometimes we might need to do some check on the database, and we would like to do that in smalltalk instead of using the SQL query applications. But that would require tools in smalltalk for us to do some custom queries, maybe merging the information that would be accessed normally to the different systems. So that's what we've been doing. And here we also want to thank some people, because what we are presenting here is just a layer, a decision that we made to construct persistence, but we have learned, and that's mostly, we think, thanks to Julian and I, who designed the velocity and have been very helpful when we started. Also, Maximiliano, who was the chief architect of everything we are presenting here. We're just the spokespeople for the development. Using it, we love what he's done, and that's why we are here presenting it and telling everybody about how we solve things, because we think it's a great solution. This is the third application Markup has for different customers, and we think it's really an improvement over how previous developments have treated the database stuff and how to solve the problems. And also Adriano, who was the main assistant to Mariano when developing this framework. So now I think we still have time for some questions. We enforce them, because there are some parts of the descriptors that is not checked when you are using the in-memory testing. And we still could do more in enforcing some checks. Now we are more focused on doing the development and taking advantage of the fact that it's just a collection when we are in memory. And that's why we try to change to relational database persistence when doing the final test before meeting every issue.
It's not required to. It's not necessary to define all the descriptors when you work on the script. You can add it, but they will be ignored. So it's not necessary in the initial testing. That's why we define descriptors that describe how to create your objects. You don't have to define the object directly. So it's not necessary to define all of them. When working memory, in database you need to.
I remember that you had a feature where you could do a select using a block. And there was a field to connect in and collect the messages and then create the select, the select based on that. Why didn't you follow that idea? Well, did you have limitations?
We are using it.
This
is being used internally by part of the query filters. The query filters fall back on that, on block behavior.
But why don't you use the same idea of, write a select with a block instead of creating an instance of,
because we want to be able to, for instance, let the user, we are not showing maybe the application here, we just have 30 minutes of limited talk, just to give you an idea. When the user has when you have the user interface and you have different filters, you wanted to let the user create dynamically the filters.
Oh, yeah, that's fine, but
so we could use small talk. For the programmers, you could do it.
You can write a select with the block.
It will work. It will work and it will translate up to a level, but since the system, in the system layer, we are trying to abstract the fact that you might be working with collections. We want to restrict the information from the outside. Everything that impacts to a system is done through a request. The request could be created by the user or by us because internal decision. Any more questions? Yep.
Since you are really focused on the creation of how do you handle the instance creation?
Sorry, then?
How do you handle instance creation? You are going to be database logic.
There's never a transition with live objects because you decide on the persistent system implementation when you start up the system, when you load the composite system. So what you could do, I think, because if you start the relational database version and you create objects, they will be stored in the database. Okay? But if I then shut down the system and I want to create a new system and I don't connect it to the database, it will start empty. So there's never a connection between the memory objects and there's no partial position there. It's either everything in memory or everything in the database.
How do we create an object that...
If you're running the relational version, right? How do you handle instance creation? Do you require something for the objects? Or what do you do?
No, if we create an object, we create in memory, the virtual machine image, and then you are using the relational persistent system, it will eventually be equivalent to an insert clause, and it will insert it in the database. And Glor will help us maintain the role in the database with the object in memory. That's just Glor handling.